RE, and if I use the tab, it gives to me river, which means that is not sure. There are two options, and if I type the tab 2 times, it gives to me the two options, river flow and rivers. I don't understand what rivers is. Probably it's a function. Because, you know, when I define my variable, I don't think there is a variable called river, no. So if it gives to me the two options, means that he has an internal variable that usually is a function that has name rivers. And you can use the same aid in completing your names for function. You see, I put EX and then tabs 2 times, and I got a list of all the functions whose name starts with EX. This is very useful. And also you have X here, it's there. Now I am curious of what is the function rivers, so let me try to get the help for rivers. I am just curious because I don't know it. Let me clear the screen. Let me see what it is. It's length of major North American rivers. I didn't know this function. And it's a vector with 141 observations. This is nice. And you could try to just type rivers. Okay, it's difficult to read. It's just a vector with the length of the rivers, and there is no river name. So it's not really very useful. But in this case, I have the opportunity to introduce to you vectors. Because now we know the variables, so let me clear the screen. The variables like river flow, it's 100 because I defined it. Now let me define a vector because a useful thing, first of all, before I define the vector, two things I want to say. You can use variables to compute operations. So if I can, I can use river flow times 2 like it was a number. Okay? And the second thing is that I can remove it. And then it's gone. Keep in mind that this operation cannot be undone. And in general, this is a general consideration that you have to keep in mind. With Linux, Linux is less protective in your respect for mistakes. Windows, from this point of view, protects you a lot because it has also the trash, and in Windows you can undo a lot of operations. By default, Linux is oriented to an experienced user, and by default it doesn't give to you the opportunity to undo the operations. When it evolved recently, Linux adopted a kind of protection as well, but only some programs. Not every program, so you still have to consider that Linux doesn't protect you on this. And given that R, even if you're using it under Windows, it's Linux based, when you remove a variable, there is no way to undo this operation. I will tell you later how to protect yourself against mistakes, okay? But in general, keep in mind that in this case, I removed river flow, there is no way to get it back. It's not Ctrl-Z, Ctrl-Z, Ctrl-C to get to... There is no option to get the operation undone. Okay. Now, vectors. It's useful, of course, to define vectors, and you can define a vector in the same way in which you define a variable, but you have to keep into account a little complication. So, A equal to, and it's a vector. You can just define a series of numbers, but you need a function to define a vector. So to define a variable, you just put A equal 10. To define a vector, A equal, and the function is called just C. And the argument of the function is a series of numbers that you want to include in the vector separated by a comma. Here it is. And of course now if you type A, you get the vector back. What is extremely useful in this type of programs is that, let me clear the screen, if you type A times 2, you get the double vector, which is very useful. So you can compute operations on vectors in the same way as you compute operations on single variables. And so you can take A to the power of 2, for instance, and you get the vector to the power of 2. This is very useful because it is a way that is similar to the way that Excel adopts for computing operations in series, not in series, contemporarily. So in Excel what you do is you write a formula in a cell, and if you want to perform the same computation on a series of cells, you copy the formula. In this case, you can do the same. You define a vector, and then you compute the operation on all the elements of the vector. It's very simple. And also you can extract a single element of a vector. So if you put A, bracket parentheses, 1 between brackets, you get the first element. If you put 2 within brackets, the second element. And what's very nice, there are a series of operations that you can do with the vectors. I just want to show you some of them. And first of all, if you want the first 2 elements, you can use this option to visualize the first and the second. If you want the first and the third, sorry, the first, the second, and the third, you have to do that. If you want the first and the third, no, sorry. The first and the third, I don't remember. Let me see. No. I don't remember. There is for sure the way to get the first and the third without the second. But anyway, we will inspect later how to do that. And another issue which is very interesting, if this is the vector A, if you put A and then bracket A greater than 30, you get a subvector with only the elements that are greater than 30, which is very useful. You have a question?
The vector, is it a row vector or a column vector when you define it?
It doesn't matter, it's because if you define a matrix, I will tell you later on how to define a matrix, then the distinction between row and columns is important. For a vector, it doesn't matter what's... did I understand well your question? You asked me...
I mean, like, you can have like a vector as a row, but you can also have one, if you transpose it,
yeah.
then you get the...
But does it make a difference for you if a vector is in a row or in a column? I don't think this is important. If it is a matrix, then you get the transpose. But can you define the transpose of a vector? I don't think so.
I can't find like a concrete example now, but
okay.
I just want to know if it's like a function for it.
In any case, R doesn't make any difference for vectors between vectors in a row and vectors in columns. Okay? It doesn't make any difference. It needs it.
But for matrices, it does that. For matrices.
Okay, I understand. Maybe that I'm not, maybe that I don't really know the reply to your question, so I'm not an expert in vector and matrices. I tell you that I never used this distinction in R, but maybe it's possible, okay? Because when you compute, you can compute operations with vector and matrices. Okay, let me explain to you. Okay, in any case, because I'm introducing the matrices now. Okay, in any case, I think with vectors we are done. Just let's consider that you can also put this, and I think it only accepts the double equal, yeah. So keep into account that when you use the equivalence sign to extract elements of a vectors, it wants a double sign of equal. And don't ask me why, because these are, let's say, symbologies that were taken by previous version of the program, and there must have been a reason why they did want to put a double sign to identify elements of a vector, but I don't know it, okay? And of course there is sometimes a bit of a problem, because if you don't know this symbology, it's not easy to get them. Okay, now let me turn to matrices, and you can define matrices of any dimension, meaning that usually a matrix is defined in 2 dimensions, so you have row and columns, but you can also define a 3-dimensional matrix or a 4-dimensional matrix. It's not a problem. The only problem is the amount of RAM memory that your PC has, because when you define variables in R, the variables are not loaded on the disk. They are kept in the ARM memory. And if you define matrices with a lot of dimensions, it's not so difficult to exhaust the memory of the PC. And I have in my PC, not in this one, but in the other one I have 12 gigas of ARM memory, which are really a lot, I mean. But I was able once to exhaust the memory by defining a matrix that had a dimension of 365 times 10 times 100, I think. And if you increase the number of dimensions of matrices, you have to be careful, because if you get the memory exhausted, then probably the PC crashes. So you have to be careful on that. And there is, on the web, you can find help to identify the maximum dimension of a matrix that you can define in whatever program, depending on the dimension of the memory of your computer. So usually users don't experience any problem unless they try to define a matrix with many dimensions. So be careful of that. 2 dimensions is not a problem. To exhaust the memory with 2 dimensions of a matrix is not a problem. Usually you don't succeed in it. But if you use a matrix in 3 dimensions, you can easily exhaust the memory of your PC. Okay. So let me explain to you how to define the matrix. And there are many ways to define a matrix. Usually I put the numbers that I want to plug into the matrix in a vector, and then I transform the vector in a matrix. This is what I usually do. But there are other ways. I find that my way is very quick and simple, so usually I use that. So let's suppose that I want to create a matrix 2 times 2, and the number in the matrix are, you can go by rows or by column, it's not a problem. I define the vector A, or let's say I already have it, and let's suppose that I want to transform this matrix, this vector in a matrix which has 10 and 30 in the first row, and 40 and 15 in the second row. So I would say, I would write A1 equal array A, dimension equal C2 times 2. Let's see what is A1. It's here, but I didn't get the matrix as I wanted to get it, because I got 1, 10, and 30 in the first column, not in the first row. So, given that I am not happy, let me see what happens if I transpose it. And this is what I wanted to get. So, let me transpose it. A1 equal T, A1. I'm sure there is a way to get the right matrix with only one instruction. So now, if I write A1 again, I have the matrix in the form that I wanted to get. And you see the indexes of the matrix in the first column and in the first row, in the headers. So you can get A1, sorry, 1, 1, which is 10, A1, 1, 2, which is 30, but you could also get A1, 1, comma, and that's it, and you get the first row, or A1, comma 1, and you get the first column. And of course you can make operations with the matrices, so you can write A1 times 2, no problem. And also now let's try, given that you asked the question, to multiply the matrix with a vector. Of course the vector has to have a dimension 2, so let me define a vector B equal C 1, 2. So now we have A1, which is this one, B is this one. Let's try to compute A1 times B. Should become a vector, it's a matrix. So let's see what it did. Okay, it multiplied. It multiplied the first row by 1 and the second row by 2. Yeah, this is what he did. So this is not really the multiplication between a matrix and a vector. It's something mixed, basically, as I said, it took the first row of the matrix and multiplied it for the first row of the vector, and the second row multiplied by the second element of the vector. So for sure there is a way to multiply the matrix times the vector, and let's say, maybe it is vectorial, let me see. No. Okay, well, one challenge would be to find out how to do that. For sure it is very simple. And what I would do is to go to Google and try to look on it. I'm not doing it now because otherwise we are running out of time. We are spending 10 minutes on this, and so this is a task that I may leave to you. Okay, and the next time I make a research myself, and then we make a comparison of what we found. Now, first of all, there is an important thing that I wanted to tell you. When you learn how to use a program, and in general, when you plan your professional activity, it is extremely important that you find the quickest way to solve your problem. This is, as I said, extremely important, and there are some people who say that quickness and rigor cannot be matched, meaning that if you are quick, you are not rigorous, and vice versa. This is not true. You can be quick and rigorous, I tell you, for sure. And this must be your target. Of course, when you make a design, when you project something, you can't make mistake. But on the other hand, you also have to be quick, because it makes a difference between you and your competitors. But even if you don't like competition, and I tell you that your clients, if they have the opportunity to choose between two people for performing a task, they choose the quickest one. Of course, they look for the more rigorous one. But if the two people are both rigorous, they choose the quickest one. And I tell you that timeliness today is really a rare quality. There are only a few people that are able to provide timeliness. And if you can provide timeliness, you are much appreciated in your career, in whatever you do. If you are a researcher, if you are timely, you have success. If you are a professional engineer, even more, timeliness is extremely important. But as I said, even if you don't like competition, it makes your day much more easier if you can reach your target in the quickest way. And I tell you, this is really very important. So this is an advice that I feel very confident to give to you. And this is extremely important, especially if you have to perform repeated tasks. Because if you have to make a computation, and this computation is to be done 100 times, and every time you save 10 seconds, at the end you have saved 15 minutes, and you have time to drink a coffee and to relax. And sometimes during the day, you make more than 100 tasks. You make like 1,000 tasks, because in our routinary, given also the aid that we get from the PC, very often we perform the same kind of computation like 1,000 times in a day. And therefore, if you can find a way to make the same computation, to use a relationship, or a quickest way on the PC that allows you to save 10 seconds every time, you don't realize it. You think it's a nuisance. But at the end of the day, you saved 1 hour. And you have time to go out for jogging, to spend time with your family or with your partner, and it makes your day much, much easier. Sometimes I see two people, and one is very busy, he works 14 hours in a day. The other one is very relaxed and it works like 8 hours, but they perform in the same way. It means that the second one is more efficient. He found the quickest way to reach the target. And I can tell you that if you find the quickest way, it's also easier to be more rigorous, because you are less hurried, you are more relaxed, you took time to drink a coffee, to chat with people. So this is extremely important. So when we learn to use a program like this, it's extremely important to find the quickest way to multiply a matrix for a vector, times a vector. And also, as I told you before, I define the matrix in this way. First I define the vector, and then I define the matrix. If there is a way to directly define the matrix, you have to learn it, because you save in this operation like 10 seconds, which is not insignificant, it's very significant. Count the number of tasks that you perform in a day and try to save 10 seconds for each one of them. So, and I know that you think that this is a strange advice that I'm giving to you. I invite you to check during your day, and I tell you that my experience really suggested me that when I was able to make a difference in terms of timeliness, I succeeded. Okay, so after the philosophy, let me go back to vector and matrices. And now I mentioned to you that you need to protect yourself, because these vectors and matrices are not saved on the hard disk of your PC. If the PC crashes, you get nothing done. It's like you work in Excel and you don't save the file. If you get a crash, you lose it. So first of all, be concerned of this, because this is a risk that is, let's say, this is a kind of problem that is not frequent. But the damage that you get is potentially enormous. So if you multiply the probability for the potential damage, you get a significant risk. So don't underestimate the risk that is connected with the crash of the PC, or the electrical power that goes down for a while, or whatever. And don't underestimate the risk connected to the hard disk or pen drive failure. These things happen, and happen frequently. So you always have to have your work saved in more than one place, and try to pay attention to your security. Security meaning protection against the failures of the hardware. Because, you know, as a student you could say, okay, I cannot give the exam now, I give the exams in 2 months. But when you are a professional, it's really a kind of it's really a kind of problem that you can bring you to a nervous breakdown if you lose 2 months of data, 2 months of work. So, how to protect ourselves? First of all, we have to learn how to save the content of R. And it's not just variable. R has also another content that is important, which is the past history. Try to use the upper arrow, and you get a replica of all the instructions that you typed from the beginning of this lecture. You see? This is 2 plus 2, the first instruction that I did. This is extremely useful. Now I'm going down. This is extremely useful. Extremely. You have a record of whatever you did in the PC, but of course you have to save it. To get this record, you also have this function, history. You see, this is the past history of today. This is extremely useful because if you go back home and you want to repeat what you did here today, it's very easy. But of course we need to save it. Okay, there is a very easy way to save everything in R, which I always use, and to me is the quickest way, but maybe that you can find a quickest one. And the way that I use is to quit R with this function, and when I press enter, I get this question, save workspace image. I don't know what C means, but I know what Y and N mean. So if you press N now, everything is lost with no opportunity to recover.
C is cancel.
Cancel, okay, cancel, let me try. Good, thank you. So, again, if you press N, you lose everything with no opportunity to recover. Let me press Y, and I go back to my console, and probably you go out from R in Windows. But when I start again, and the same for you, when you press on the icon again, you see here, caricato workspace precedentemente salvato, which means that I loaded the workspace that you previously saved. So, if I use the upper arrow, I have everything here. And if I look at the variables, everything is here. Now, so what I do usually while I'm working, every 10 minutes, 15 minutes, I just go out and then log in again. Back and forth. But there are instructions to save, alternative instruction. One is save history, file equal, and then you have to provide a file name. I didn't provide any file name, and therefore it tells me I had a problem. But if I make save history file equal r.txt, I got the history saved in a file. There is the way to, let me see, to save the variables and all the workspace without getting out of the program. Let me see. Save writes an external representation of the R object to the specified file. The objects can be read back from the file at a later date by using the function load. So, let me see, let's try. Save. Let me define a new variable first. Prova equal 1000. And then let me see, let me try save. And I use the file name is let me see, file. Nothing specified to be saved. Let me see what he wants to. No, this is not what I was looking for. Failed image. Okay, save image. Sorry, it is this one. If you cannot follow me, just let me know. Okay, save image, file, equal, Good. Now, apparently, I saved the image, which means everything, to a file that is named prova1. Let me try to go out from the program and to press N now, without saying anything. And let me get back to the program now and try to load the image that I saved, to make a check that everything was successfully saved. So let me try load prova1. And let me see if the variables are all there. Yes, they are all there. And also the history. The history is not there. Or, no, I'm not sure. No, it's not there. So everything was saved, but not the history. Now let me go back to that for save. And let me see similar functions. I'm looking for similar. Maybe done. Anyway, let's move forward. Basically, the moral of the story is I never took the time to really inspect how to save everything without exiting from the program, because I found very handy to go back and forth, out and in and in this way I get everything saved. But there is a question that you should ask me: where is the file where R saves everything? So this is a bit of a problem for me to tell you, because I know the answer for Linux, but I don't know the answer for Windows. So basically, the file should be in the directory where the executable file of R is. So in Windows, you have a directory that is called programs, or programmi in Italian. And this directory is usually, if you look in the folders of your PC, under your personal folder. And this is the directory where programs get installed. And in this directory programs, you have a subdirectory which is called capital R. So R in capital letters. And in this directory, you should find the file that you saved. Okay. Okay, so we got to the point where, close to the end of the lecture, but we got to the point where we are now able, please.
What's the format of Prova TXT now?
No, this is an image file, it's a binary one. So it's a binary file. And this is not a text file. So, but you should find it in, if you look for the name of the file, and you look in the pool hard disk, you find it. Of course, if you specify the name of the file when you make a save with save image, you can specify also the path of the file. So you can tell to the PC where to save it. And in Windows, this is a bit of a problem, because Windows is always, everything is hidden. So to put the file on the desktop, you need to tell Windows the path of the desktop. Probably it's easier to save the file in an external USB or something like that. But if you have problems in solving this problem, in finding the file, next time, if you bring a Windows computer to me, I can easily track it down. So we can solve this problem together if you get in trouble. Okay, now let me conclude by giving a very quick introduction to graphs, because it's, to give an introduction is very easy. And let's suppose that we have a vector that we want to plot, and I have several vectors here. Let me see. I think I have, sorry. I think I have a vector that is called A1. Or A. A is a vector. Now, let's suppose that we want to plot this vector that is called A. So, plot A. That's it. Of course, the plot is not really nice. It's very basic, but you can see everything here. You see, you have, sorry, there is, probably you can't see well, but there is, in the y-axis, there is a label that is index. Index because we just plotted a vector of 4 elements, and therefore the index are from 1 to 4. And then in the y-axis, it's not visible, but there is written A, which is the name of the vector, and you see the 4 points. Of course, you may say, I don't like it, it's too basic.